Okay, let's talk about satellites. So there are two types of satellites that we're going to discuss today. The first one being geostationary, and the second one is polar orbiting. So let's focus on geostationary for now. What is a geostationary satellite? Well, it's pretty simple. The name already kind of suggests it. If you consider your world here, and it is spinning around its axis at 24 hours per revolution, i.e. its standard daily rotation, then you can imagine having a satellite that is out in orbit completing one orbital revolution in exactly the same 24 hours. And this satellite is looking down at Earth and sees, because it is far away, almost one half of Earth's surface. And since this satellite is spinning at exactly the same angular velocity as Earth, it will always be centered around exactly the same point. And that is why these types of satellites are called geostationary, because the satellite is stationary with respect to a fixed point on Earth's surface. And so the area that the satellite covers is exactly always this area that we see here. So let me write these things down. So it has a 24-hour period. The distance from Earth to the orbit is roughly 36,000 kilometers. So this is a very far orbit. Another requirement for this to work is that your satellite has to be roughly with its orbit in the plane of the equator, so that the axis of rotation for the satellite is approximately the same as the axis of rotation for Earth. So orbit must be close to equator. The next thing is that this coverage here, the latitudinal coverage, is about plus or minus 70 degrees. So that is one of the limitations of geostationary satellites, is that they don't really observe the polar regions. So I'll indicate those by red here. So what are the pros? Well, the main pros for geostationary satellites are that you get continuous imaging of the same region, and that you can cover a really large footprint, cover almost entire hemisphere. Now, what are the cons? Well, disadvantages of geostationary satellites are that you get fairly low resolution since they are so far from Earth, and they don't cover the high latitudes. A couple of famous examples for geostationary satellites are the GEOS East and GEOS West satellites, which are essentially responsible for most of the weather data that we see, especially over North America. So whenever you see hurricane images or other weather bands coming through, that is typically one of the GEOS satellites that delivers our weather data. Okay, so since we don't have a high resolution and don't cover the high latitudes with these geostationary satellites, we are next going to look at polar orbiting satellites. They have other limitations, but they have the great advantage of covering the polar regions, and they are flying at low altitudes, and as a result give us very high resolution data. So if here I have my Earth focused on the Americas, then my polar orbiting satellite will fly in an orbit that runs over the equator. You can imagine it goes like this, and comes back up, and it looks downward, so it covers a given swath of the Earth's surface. So this is what it will see on its first trajectory. Now, the Earth is rotating, and you can imagine that the next time round our satellite comes across, it will cover a different meridional trajectory compared to the first one. Now the Earth has rotated and our satellite is going over a region further west. And this happens again and again. And then it comes around again. And interestingly, since Earth is rotating at an angle, on every rotation, the meridional trajectories of our satellite are going to be slightly shifted. And as a result, you're covering over time all the different surface areas of the globe. So all polar orbiting satellites have an altitude that's much, much lower than the geostationary ones. They are about 700 to 800 kilometers altitude. They have a rotational axis that is at about 90 degrees to the equator. That's what we call the inclination, 90-degree inclination. And they go much more quickly around Earth. It takes them about 100 minutes per revolution. But obviously the footprint now is much smaller, right? So you only see a given strip, a given part of a given strip at any time, unlike the observations from the geostationary satellites, which cover almost half the globe at any given time. So the pros for polar orbiting satellites are high resolution, since they're close to Earth, and they cover the whole globe. Yeah, so you don't have these polar regions that can't be observed. In fact, the polar regions are the best observed for polar orbiting satellites. And the cons here are that you only image each spot around 2 times a day. Only twice a day is that you get your coverage for each surface spot on Earth, which still is not that bad, but obviously much worse than the geostationary, which basically cover every spot every few minutes or so. Now, let me give you one example of a maybe not so famous polar orbiting satellite, but certainly famous for us, and that is the Seahawk CubeSat, which is a tiny little satellite. It's roughly the size of a loaf of bread, and it measures sea surface color, ocean color, and it was designed and is operated in parts by a UNCW run project. So we have kind of our own satellite.